Hi, welcome to the video solution from mechanics. This is Edexcel IAL M1 January 2017. Let's start. Question number 5. Two particles P and Q have masses 4m and km respectively. They are moving towards each other in opposite directions along the same straight line on a smooth horizontal table. When they collide directly, immediately before the collision, the speed of P is 3u and the speed of Q is u. Immediately after the collision, both particles have a speed 2u and the direction of motion Q has been reversed. Find in terms of K, M and U the magnitude of impulse received by Q in the collision and find the two possible value of K. So situation is you have two particles P and Q. So this is P and the mass of P is 4m and moving in that direction with the velocity 3u, and this is Q, mass km moving in that direction with the velocity u, and collision between these and the direction of Q is reversed and both particles are moving at the same speed. So the speed of Q after collision is 2u. We are not informed about the direction of the P for part A, so it's fine, I'm not drawing. So I am considering, remember in all momentum question direction of motion is important, so you need to take any one direction as positive, then the other direction will be negative. So generally I take rightward direction as positive and the negative leftward direction as negative direction. That means this velocity u I will be considering as negative velocity and 2u will be considering as positive velocity. So the 3u also for me is a positive velocity. So I need to find the impulse. Impulse is I is equal to change in momentum of that body on which we are finding impulse. In this case we need to find impulse on Q. That means I must be equal to change in momentum is m into delta v. M is the mass of the object, delta v is a change in the velocity. So I is equal to mass of the particle Q, which is km, into change in velocity. So final minus initial. So final velocity is 2u minus initial velocity, and initial velocity is minus u. So you can see that 2u minus plus u. So overall impulse on Q is 3u times km. This is impulse on Q. Okay. Part B, find the two possible values of K. Why are they saying two possible value of K? It is because if you read the question, they did not give the direction of the particle P after collision. That's why there are two possibilities, whether the P is moving in the same direction as Q was moving, or P also reverses its direction. So that means there are two possible cases. So case number one, you say that if P is moving in positive direction. Positive direction means as the direction of the Q. So you say that you have a particle P 4m, initially moving with 3u velocity, particle q, k, m, moving leftward with the velocity u, and after collision, q is moving with the velocity 2u, and p is also moving in the same direction. This is p in the same direction with the velocity 2u. It's not 24, it's 2u. It is 4m. So in this case, I'm going to apply law of conservation of momentum. So momentum before, momentum p before equal to momentum p after. Is my short form I'm writing just to save the time, but you must write momentum. This p is momentum. So momentum before equal to momentum after. So momentum before is 4m. That means this is before and this one is after. So you can see that momentum before is 4m into 3u plus km minus u. So I'm considering negative velocity of q because it is moving in negative direction. So momentum before of p and momentum before of q equal to momentum after. Both are moving in the same direction and which is positive one. So 4m into 2u plus km into 2u. So you can say that this is I just need to rearrange for k. That means I have equation 3k mu is because 2k mu and minus kmu. If you send minus kmu on the other side, so you have a 3k mu is equal to 4 mu, and you can cancel u with the u, m with the m, so you have k is equal to 4 by 3. This is first possible value of k. For second possible value of k is, you assume, case number 2, you assume that your p is moving in negative direction. If it is moving in negative direction, that means you make arrow of p in that direction. That means this 2u would be considered as minus 2u. So in this case, momentum before remains same. It will be same. But in momentum after, for particle p, it will be minus 4m2u. And again, if you do the same thing, rearranging for k, gather all the k terms and send rest of the other term on the other side, so you will find k is equal to 20 by 3. This is the second value of k. I hope you understood what I meant to say. Question number 6. A particle p of mass m 4 kg is held at rest at point A. on a rough plane which is inclined at 30 degrees to the horizontal. The point B lies on the line of greatest slope of the plane that passes through A. The point B is 5 centimeters down the plane from A as shown in figure 3. The coefficient of friction between the plane and the P is 0.3. The particle is released from rest at point A and slides down the plane. Find the speed of particle P at instant it reaches at B. So situation is you have a particle at A at rest, and then you are releasing this particle from rest, and then it is sliding down and reaches at B, and you need to find when the velocity of the particle V when it reaches at P. So initial velocity is 0. Initial velocity is 0. So it is clear a question of equation of motion because initial velocity is given as 0 and you need to find the final velocity. So and the distance is also given. So the easy approach for this question is I can use S equal to ut plus half at square, or the better option is v square is equal to u square plus 2as. Yes, this is better option than this because time is also involved. There's nothing to do with the time for the meantime. We might need later on, but not now. So the best option is we should think about this equation to find the final velocity. But the problem is we don't have acceleration. That means before using this equation, we need to work out for acceleration. If we can manage to find the acceleration, then we can find the velocity at point B. So let's try to find acceleration. Now, you know that on an inclined plane, you have a particle P, and then in this case there are some forces acts. One force acts, this is mg downward, this is contact force R, and because this is a rough surface and particle is sliding down, so the particle is acted by some frictional force F. So particle is under influence of three forces, and before doing something we need to resolve weight into its component, and you say that I have one parallel component and one perpendicular component. So this is down and this is along the plane. If this angle is theta, inside this triangle we have the same angle theta. For this component, the green one, it is a parallel component of the plane, it is acting downward. This component always acts downward, so the value of this component is mg sine theta, and the value of this component is mg cos theta, and then we equate accordingly the respective component and we have a system of equation. So we always do, whenever we have an inclined plane, we always resolve forces into components, and before doing anything we must write system of equation, at least two or maybe three equations. In this case, because we have a rough plane, so we must have a three equations to deal with. So let's see, if I am resolving forces perpendicular to the plane, that means in that direction, perpendicular to the plane, this R means resolving forces perpendicular to the plane. So in perpendicular, if I have a force, a particle at point A, in that direction, I have two forces acting. R is acting upward and mg cos theta is acting downward. So I can write that the first equation as R equal 4g cos of 30, because this angle is 30, so inside angle is 30. So 4g cos 30, and moreover I can write cos 30 as 4g cos 30 is under root 3 by 2. That means under root 3 by 2, so 2 and 2 cancel, so R is equal to 2 root 3 g. Equation number 1. Next is I'm resolving forces parallel to the inclined plane. Parallel to the inclined plane. That means I'm looking for all the forces acting parallel to the plane. So if you see the diagram, parallel to the plane, I have two forces acting, mg sine theta down the plane and friction up the plane. So I can say that, and of course particles is sliding down, so we have a net force in downward direction. If we have a net force in downward direction, that means mg sine theta, mg sine theta is greater than friction. That's why a particle is sliding down and we have a net force, and net force we can write as mg sine theta, and in place of m it's good to write 4g sine 30. This is sine 30 minus friction F is equal to net force, and net force is MA. MA means 4A. And you can simplify this equation after putting value of sine 30, which is 4g sine 30. Sine 30 is half, and F is mu R. Mu R means 0.3 R, because coefficient of friction is 0.3, and you know that F is equal to mu R. So you can replace F with the mu R, 0.3 R, and 4A. So this 2 will get cancelled. That means 2G minus 0.3 R is equal to 4A. This is equation number 2. These two equations are called system of equation, and after this you will have to solve these equations simultaneously and you can figure out the value of A. And just don't worry, it's just a simple equation, just like in algebra. If you have a two equation, x plus, it's just example, x plus 2y equal to 3, and 2x minus 4 minus y minus 2 equal to 0. If you have these two equations, if you are asked to find value of x and value of y, what do you do that equation? Definitely you say that I will solve the equation simultaneously, meaning even either substitution method or elimination method. So you can use any one of the method to solve these equations to find the value of this acceleration. If you solve these two equations using simultaneous method, either elimination or substitution, you have acceleration A is equal to 2.35 or 2.4 meter second minus 2. This is the acceleration. Now you can use equation of motion to figure out the velocity. So since v square is equal to u square plus 2as, and U is 0 and S is 5 meter. A you have already found, which is 2.35, so you can figure out this value of V. If you substitute all these values, so V would be equal to 4.85 meter second minus 1. Next part, the particle is now returned to A and is held in equilibrium by a horizontal force of magnitude h Newton, as shown in figure 4. The line of action of the force lies in the vertical plane containing the line of greatest slope of the plane through A. The particle is on the point of moving up. This is important statement. Moving up the plane, find the value of h. So now, other than weight, normal reaction and friction, we have fourth force h newtons acting parallel to the ground on the particle. And due to this particle, due to this force h, the particle is about to move up the plane. That means if you see the forces acting, so you can say that we have R acting perpendicular, this is R, and we have a perpendicular component which is 4g cos theta or cos 30, and we have parallel component. I'm drawing is down the plane, but it is, this component is in fact up the plane. You must, if you can draw here, or just do, otherwise you will be confused. So you have, this is 4g sine 30. Along with 4g sine 30, because particle is about to move up the plane, we have friction downward. So you can draw friction. Where should I draw? It's okay if I draw here. So remember, in that direction, I have friction F. Just to make you understand, I drew F here. F is between the plane and the particle. So down the plane, we have two forces, 4g sine 30, again, sorry, it's a 30, and F. So these are the forces, but if you see H is acting parallel to the ground, so we have component of H acting on the particle, so we must find the component of H, and you can visualize this is the component of H, and this is another one, and this is a downward. Okay, so if this angle is 30, you can say that inside this triangle, this is alternate angle, so this one is 30. That means this is opposite component, so the value of this opposite component would be H sine 30, and this H sine 30 is acting downward, and this parallel component, this one, is acting up the plane, and this is adjacent one, so it will be H cos 30. Now I have all the forces that I have resolved. Now I just need to write system of equation. So resolving forces perpendicular to the plane, and you say that perpendicular to the plane, I have three forces. R is acting upward, 4g sine 30 down, 4g cos 30 downward, and H sine 30 downward. So I can say that I have 4g cos 30 plus h sin 30 is equal to r. You can simplify this equation after substituting the value of, I'm just not doing this. Okay, fine. This is equation number 1. So this is perpendicular resolving forces, and then parallel forces parallel to the plane in that direction. So in parallel in that direction, I have h cos 30 acting upward, 4g sin 30, and f acting downward. So I will write as f plus 4g sin 30 equal to h cos 30. This is equation number 2. So, or you can say that you have another one more equation, f is equal to 0.3 r, equation number 3. Now you have your system of equation, three system of equation. You can solve these three simultaneously to figure out value of h, either by elimination method or substitution method. I will do just for you combine step. If you can understand that I will be dealing both equation together. So what I'm doing, I'm equation number 1, I will substitute the value of cos 30 and the sin 30. So I would have 4g cos 30. Cos 30 is under root 3 by 2 plus h sin 30, and sin 30 is half. So, and then is equal to r. The equation number 2, f, I'm writing f as a mu r. So 0.3r plus 4g sin 30. Sin 30 is half, is equal to h cos 30. Cos 30 is under root 3 by 2. And then this 2 will cancel this 4, and this 2 will cancel this 4. So this these are the two equation. You can say that 1 and 2 implies. So you change both equations together. So finally you have 2 root 3 g plus h by 2 minus r equal to 0. I'm sending this r on the other side, and for second equation I'm writing 2g. I'm writing this term first, so it doesn't matter. I'm writing this term first, so this is 2g, and I'm bringing this h on the other side again, so minus h root 3 by 2 minus 0.3 r equal to 0. So now clearly you can see that you can eliminate r easily, because this is coefficient 0.3 and this is coefficient 1. So in elimination method you must have a same coefficient. So you only multiply equation 1 with 0.3, so you can cancel this 0.3. And I guess I did a mistake here. This is 0.3 positive, so it must be positive. So now you can multiply the first equation of this bracket with 0.3. If you do that, if you multiply with the 0.3, so you can have 0.6 root 3g plus 0.3 by 2h minus 0.3 r equal to 0. And then second equation stays same because you already have 0.3 there. So 2g minus h root 3 by 2 minus 0 plus 0.3r equal to 0. And now you can easily cancel, and you can add these two terms and these two terms and then figure out value of h. If you add these two terms, so h finally we would have 41.6 Newton. I'm not giving you all the intermediate step because this is not M1, but if anyone wish to see each and every step, let me know in the comment section. So next time I will try to give you all possible step, but I guess at this level you must know how to add and subtract variable. This is value of h. Question number 7. Two particles P and Q have masses 3 kg and m kg respectively. M is greater than 3. The particles are connected by a light inextensible string which passes over a smooth light fixed pulley. The system is held at rest with the string taut and the hanging parts of the string vertical. The particle Q is at a height of 10.5 meter above the horizontal ground as shown in figure 5. The system is released from rest and Q moves downward. In the subsequent motion, P does not reach the pulley. After the system is released, the tension in the string is 33.6 Newton. Show that the magnitude of the acceleration of P is 1.4. Find the value of M. Okay, so this is this problem with motion of particles connected with the string, and especially in case of pulley. Remember one thing, there are two important points. During the motion, acceleration of both particles remains same. So acceleration for both particles remains same, and tension in the string throughout at every point, tension is also remains same. These are two important points that we use to solve the problem particle connected with the string and passing over a pulley. And again, the same concept. First of all, we need to see how many forces are acting on each and individual particle, and then we resolve the forces if we need, and then we need to write system of equation. So you see that for particle P, you have weight acting down, which is 3g, and tension acting upward along the string, this is T. And for particle Q, you have weight acting down, mg, and tension, because tension is same, so qt is also upward. So you see that for P, for particle P, since the particle P is moving up in subsequent motion, that means T is greater than 3g. That's why the particle P is moving up. That means you have unbalanced forces, so you must have some resultant force, and you write the first equation as T minus 3g is equal to 3a. 3a is basically net force, ma. So equation number 1 for particle Q, as particle Q is moving down, that means mg is greater than T. So you write for Q is mg minus T is equal to ma. This is equation number 2. Now you have your system of equation. Again, after this, the steps are same. You need to solve these equations simultaneously, either substitution method or elimination method. You can figure out value of A, and you can see that I guess yes, we needed this equation later on, but for first part I guess you don't need to write the equation for Q because you have T given in the question. So you can substitute t as 33.6 and you can figure out value of a. If you do that, so your value of a, equation number 1 implies that a would be equal to 1.4. If you use 33.6 minus 3g divided by 3, so 1.4 meters second minus 2. This is your acceleration. And for part B, find the value of m. So you have acceleration. Now you can substitute. So for 2, you can substitute acceleration here to figure out value of m. But before substituting the value, it's a good idea to send ma on the other side, so you have a similar term of m on one side and send rest of the term on the other side. So you can say that if you rearrange this second equation for m, so you would have m is equal to t divided by g minus a. Now you have a 1.5, 1.4, g is 9.8, and t is 33.6. So you can say that m is equal to around 4. Yeah, it's 4 kg. This is the value of m. Okay, the system is released from rest at time t equal to 0. At time t 1 second after release, q strikes the ground and does not rebound. The string does not go slack, and p continues to move upward. Find the value of t1. Okay, so the situation is you have I will do here. So this is the pulley, and this is the ground. Okay, so when the particle coming down and hits the floor, at that moment particle p is going up. So the velocity of the particle q when it hits the ground, vq, and at that moment the particle p moves at some point here. That means the velocity of p at that point, so these two velocities should be same. But the situation is particle q comes to rest immediately, but because particle p has some initial velocity vp, and then due to this velocity particle p keeps moving up and the string goes slack. Okay, so particle q is taking t1 times to hit the ground. That means from here to there the total time is t1, and in this case I'm going to use s is equal to ut t plus half at square. So s is 10.5 is equal to u is 0 plus half into 1.4 into t1 square. So you can use this equation to figure out t1, and your t1 is 3.87 or approximately 3.9 second. This is the t1. At time t2 seconds after release, p comes to instantaneous at rest. Find the value of T2. This is the situation when particle P is moving up, but you know that before it was moving due to a resultant force T minus 4g. T minus 4g. But once the string becomes slack, there is weight acting, and due to which the velocity of the particle keeps decreasing. So particle is moving up, but velocity is decreasing. Somewhere here particle P comes to rest. This is the time that you need to find. So this is the T1, and this is the additional time that you need to figure out. So T2 will be the total time of release from Q to time at which the particle P comes to rest after reaching some maximum height. So I'm assuming that this time is T. And how do we find this? Because we know that Vp has the same velocity as Vq when it is hitting the ground. So first we need to figure out Vq so we can have initial velocity of particle P. And for Vq, since Vq, the final velocity of particle Q is u plus at, this is the equation that I'm using for downward motion of particle Q. So u is 0 and a I have found 1.4, and t is the time, which is in fact t1. So 1.4 times 3.9, so Vq is equal to 5.5 meter second inverse, and this velocity is also initial velocity for P when the particle starts moving under influence of weight. So we can use this velocity to figure out this time interval. So we can do that for P. V is equal to u plus at. Okay, V is the final velocity, which is 0 at that point. U is the initial velocity, as same as the velocity of Q at time of hitting the ground. So this is 5.5 plus, now here's the key point, the acceleration. Because the particle P is moving under gravity, so we have to use 9.8, not 1.4. Remember, because a string is now slack, so we cannot use 1.4. It is 9.8 times t, and the particle is moving up, so it should be minus 9.8. So from here you can figure out t. This t will be 0.56 second. So the total time t2 would be equal to t plus t1. That means 0.56 plus 3.9. That means t2 is equal to 4.457 or 4.46. At time t3 second after release, t3 greater than t1, the string becomes taut again. Sketch the velocity time graph for the motion of the particle P in the interval 0 to 2, 3. Okay, so you will have to understand the whole motion from the release of the Q till the string becomes taut again. So what is happening? Initially, Q is coming down or falling down, string is taut, but when Q hits the ground, string goes and becomes slack. Then particle P keeps moving with the slack string under influence of gravity and reaches the height, and then it starts falling down. So the rate of increase in the velocity, because when it reaches at the top, the velocity is zero here, but when the particle P starts falling down again, so its velocity keeps increasing with the same rate, and then it reaches at that point where the velocity of the particle becomes again 5.5. So you have three instances need to mention on your graph. So let's see. This is the y-axis, x-axis. Now this is the graph showing increase in the velocity in the first interval. That means this is t1, and this velocity must be 3.9, and this time must be t1, which is 3.9 second, and then same rate, so you must have a same gradient, remember. So this is 4.5, that means this is t2, and this one is t3. This is time axis, this is velocity axis, so time in second, velocity in meter second minus 1. Thank you very much for this video. Have a nice time.